Today we're going to apply the greatest common factor and least common multiple rules and procedures to reducing and expanding fractions. So our goal, of course, is to apply greatest common factor and least common multiple to fractions. And how are we going to do that? Well, we're going to reduce fractions and we are going to make them larger while still remaining equivalent. Let's first look at our vocabulary that we're going to be dealing with for this lesson. The fraction, numerator, denominator, equivalent fractions, and simplest form. So let's get to those definitions. Let's first look at our vocabulary words. Fraction. A fraction is a number in the form of a over b, where b of course cannot be 0, used to describe parts of a whole or a set. So b cannot equal 0, of course, because you cannot divide by 0. Fractions are a form of division. Numerator is the a of the fraction, a over b, or the top part. And the denominator is the b part, b for bottom, part of the fraction. Equivalent fractions are fractions that represent the same part-to-whole relationship. And simplest form is a fraction's in simplest form if the greatest common factor of the numerator and the denominator is 1. In other words, you can't divide any more by any other numbers other than 1. So go ahead and take a minute to pause this to copy down your vocabulary. Let's look at one example. Radio. There are 12 songs played in 1 hour on a local radio station. 3 of the songs are new releases. What fraction of the songs played in an hour are new releases? So this problem is asking us a couple of things. We know we need to find a fraction, and we know that we have 3 out of the total amount of songs. Well, we know that that number is 12. So we need the number of new releases, so that's our numerator, over the number of songs. So we already know the new releases. That number is 3. And the total number of songs played in an hour are 12. So I need to basically look at equivalent fractions. So I have 3/12. So then I look at how many groups can I factor out. Again, greatest common factor. So I'm really looking for the greatest common factor between 3 and 12 in order to reduce this fraction. If my greatest common factor was 1, then it's already reduced. So I look at 3 and 12. They're both divisible by 3. So when I look at the groups of 3, over groups of songs, I have one group of 3 in my numerator, and I have 4 groups of 3 as my denominator. So the fractions 3/12 and 1/4 are equivalent because they have the same part-to-whole relationship. So the fraction of the songs played in an hour are 1/4 that are new releases. So I hope that helps you. Let's look at a few more examples of equivalent fractions. There's different ways we can make equivalent fractions. So let's multiply or divide. So we have 3/9. Well, it's really easy to multiply and make it larger. But remember, whatever I do to the top, so let's say I multiply this by 2. I have to multiply the denominator by the same amount. And that's because, of course, 2 over 2 is like multiplying it by 1 whole. And anytime you multiply something by 1, it's maintaining the same value. So if I multiply these groups of 2 on the top and the bottom, I have 3 times 2, which gives me 6. and 9 times 2, which gives me 18. So 6/18 is equivalent to 3/9. Now, looking at another example where I can reduce, you probably can tell that 3/9 has a factor of 3 that I can factor out. And that's really what you're doing, is factoring out a number. So that can give us, of course, 1/3. So the fractions 6/18 and 1/3 are equivalent to 3/9. Looking at another example. Let's look at an example where we're writing the fraction in simplest form. So now we're factoring out the greatest common factor. Well, I can factor out a 2 from both 10 and 32. Sometimes there's a higher common factor, but anytime if you are not sure where to start, if they're both even, you can always start with 2. So we can factor out a 2, which would give us 5, because 10 divided by 2 is 5/16. And then I can look at this, and my greatest common factor between 5 and 16 is 1. Therefore, 5/16 is in simplest form. So 10/32 written in simplest form is 5/16. Let's look at another example. Write the fraction in simplest form, 9/14. Well, if I look at 9 and 14, I can try to figure out common factors. Are they both even? No. That means that any even number is not divisible by either of these. So then I need to look at, okay, 3. Does 3 work? No. 5? No. So my greatest common factor between 9 and 14 is 1. That means that 9/14 itself is already in simplest form. So 9/14 is in simplest form. Now I want you to try. So write two fractions that are equivalent to each given fraction. You can do this by multiplying them. You can also do this by reducing them. So if they're already in simplest form, you can multiply the numerator and the denominator by the same number, and that number can be anything you choose. So go ahead and take a minute to practice these. So just to give you some examples, 1/15, if I multiply the numerator and the denominator by 2, I would get 2/30. And if I multiplied the by 3, I would get 3/45. Some of you might have just multiplied the numerator and the denominator by 10, 10/150. Anything that you write is sufficient as long as it is the same part-to-whole relationship. So those are just two examples. Now we have 7/15. Well, I can multiply the numerator and the denominator by 2 and get 14/30. I can multiply the numerator and denominator by 3 and get 21/45. Again, your examples might be different than my own. Just make sure you have the same part-to-whole relationship. Now in these cases, 10/12, I can reduce that because they're both divisible by 2 and make it 5/6. And then I can double it and make it 20/24. Those are just two examples. Again, your examples might be different. 20/25, both are divisible by 5, so I can reduce them to 4/5, and I can also double it, which is really easy to do, to get 40/50. Again, make sure that your answers have the same part-to-whole relationship. Let's look at one final example. Student council. Isabel and Timothy are both running for student council representative in their homeroom classes. Isabel received 18 out of 30 votes. That out of often is a pretty good hint that there's a fraction. in her homeroom. Timothy received 15 out of 25 votes in his homeroom. Write the fraction of votes received by each candidate in simplest form. Are the fractions equivalent? So we need simplest form. So we need, for Isabel, we need votes received over the total votes in the homeroom. So that would give us 18 over 30. I can divide both of these by 2, obviously, because they're both even, but let me try to find a bigger factor. Well, I know they're both even, and I know that they are also both divisible by 3, because 1 plus 8 is 9, 3 plus 0 is 3. So if they're divisible by 2 and 3, then I know they're divisible by 6. So Isabel received 3/5, and now I only have a greatest common factor of her class votes. Now let's look at Timothy. Sorry about that. So Timothy received, again, received over the total. He received 15 out of 25. Now both of these end in a 5, so I know they're both divisible by 5. And remember, whatever I do to the top, I have to do to the bottom in order to keep it the same ratio. For example, I can't divide the top by 3 and the bottom by 5. I'm going to change my value. So make sure you're checking in with yourself, making sure that you're dividing the same number or multiplying by the same number. So when I reduce that, I get 3/5. So I've written both of them in simplest form. Now I have to answer the second question. Are the fractions equivalent? Yes. They both received, and actually, I should do this in a different color. Yes, they both received 3/5 of the votes. So I hope this helps you. Now I want you to take a minute to review your notes. So go ahead and pause the video to make sure that your notes look similar to mine. So we have the first page of my notes. Again, your writing might be a little bigger or smaller, where we have our goal and our vocabulary. Go ahead and take a minute to pause to make sure your votes match up with mine. Now going on to the next page of notes, go ahead and review your notes to make sure that they have all the information that you need. Don't forget about your questions, keys, and any main ideas. Go ahead and take a minute to pause. So great job on your notes. You've done a really great job working very hard, and I'm extremely happy that you'll get very good results out of your lessons. Remember, anytime you have any questions, feel free to come with questions ready at the beginning of each period. Great job.